13,000 feet below the surface of the Pacific Ocean, something started happening that no scientist could explain. The oxygen was going up, not down, up. In a place with no sunlight, no plants, no photosynthesis, no living thing capable of producing a single molecule of breathable air. The oxygen levels inside sealed chambers on the sea floor kept climbing and climbing and climbing. Scientists ran the experiment 25 times, same result every time. They thought the sensors were broken. They threw them away and bought new ones. Same result. They poisoned the water to kill every living organism inside the chambers. The oxygen still rose. By the end, some readings showed oxygen levels more than 3 times higher than when the experiment started. In total darkness, under crushing pressure, in water so cold it would kill a human in minutes. Whatever was making that oxygen was not alive, and we still do not fully understand what it is. Hey, real quick before we go any further, where in the world are you watching this right now? Drop your city in the comments. I'm genuinely curious how far this one travels. Stay with me until the very end of this video, because the full explanation of what's actually happening down there on that seafloor, I'm saving it for last, and I promise you it will completely change how you think about life on other planets. But first, we need to go back to the beginning, because this story doesn't start with oxygen. It starts with a robot and a catastrophic loss. In 2014, a deep-sea vehicle called Nereus was exploring the Kermadec Trench near New Zealand. It was a $14 million machine, one of the most advanced underwater robots ever built. It had already produced dozens of groundbreaking scientific publications. Researchers trusted it completely. Then, without warning, it lost contact with its ship. It never came back. The pressure at those depths is roughly 1,000 times greater than at the surface. The vehicle didn't malfunction, it didn't get lost. The ocean simply crushed it out of existence. $14 million. Gone in an instant. And after that, the deepest parts of the ocean were essentially closed. Too risky, too expensive, too much to lose. That's when a deep-sea biologist named Timothy Shank decided the entire approach had to change. Shank runs a program called the Hadal Exploration System, or HEX, and his idea was radical in its simplicity. Stop building one massive, expensive machine and hoping it survives. Build many small, cheap ones instead. He called it the CubeSat philosophy, borrowing directly from the space industry, where tiny, affordable satellites are launched in clusters rather than relying on a single billion-dollar spacecraft. And to build it, he turned to NASA. Together, they created something called Orpheus. Named after the figure from Greek mythology who descended into the underworld, Orpheus is roughly the size of a motorcycle. It weighs about 550 pounds, and it costs less than $200,000 to build. Compare that to the 14 million Nereus required. 2 identical vehicles were constructed, named Orpheus and Eurydice after the mythological pair who walked through Hades together. But here's what makes them genuinely extraordinary. The navigation system inside Orpheus was built by NASA engineers. It's called Visual Inertial Odometry, and it works by doing something almost human. It remembers landmarks. As Orpheus moves across the ocean floor, cameras scan the terrain below. Rocks, shells, coral fragments. The software identifies them, stores them, and uses them to figure out exactly where the vehicle is at any given moment. Think about how you navigate a new city. You spot a red building, a fountain, a specific corner. You remember them and use them to stay oriented. Orpheus does that exactly, except it does it in pitch black water under pressure that would collapse a submarine. And here's the detail that should genuinely blow your mind. That exact same technology, the same fundamental algorithm, helped NASA's Perseverance rover land safely on Mars in 2021. One system, 2 worlds. One of them is Mars, the other is the bottom of our own ocean. Because down there, just like on the surface of Mars, there is no GPS,
no satellite signal, no outside reference point of any kind. The vehicle has to navigate entirely by its own senses, entirely alone. And while Orpheus was being tested in the deep Atlantic, running practice dives off the research vessel Neil Armstrong, creating three-dimensional maps of seafloor nobody had ever seen before, a completely separate team of scientists was making discoveries that would force everyone to rethink the most basic rules of biology.
In 1977, everything we thought we understood about life on Earth collapsed. Scientists exploring the ocean floor near the Galapagos Islands found something that should not have existed: cracks in the seafloor, hydrothermal vents, superheated water pouring out of the Earth's crust at temperatures that should sterilize everything within reach. And surrounding those vents, life. Enormous, thriving, complex ecosystems. Tube worms taller than a person, shrimp piled on top of each other in dense colonies, microbes coating every surface. None of them had ever seen a single photon of sunlight. They were not running on photosynthesis. They were running on chemistry, breaking down hydrogen sulfide, processing methane, extracting energy from the rock itself. Biologists call it chemosynthesis, and before 1977, most scientists believed it was essentially impossible as a basis for complex ecosystems. They were wrong. And since then, the deeper we've looked, the stranger it's gotten. In the Caribbean Sea, NASA scientists from JPL have been studying a species of shrimp called Rimicaris hybisae. These tiny creatures stack themselves on top of one another, clinging to rock chimneys that vent water heated to 750 degrees Fahrenheit. The water just 1 inch away is cool enough for them to survive. They are completely blind, but they have thermal receptors on the backs of their heads that allow them to sense heat with extraordinary precision. They position themselves at the exact boundary between scalding death and tolerable warmth, a margin measured in millimeters. Bacteria living inside their mouths and gill covers produce the organic matter they feed on. The whole ecosystem runs on chemistry, not light, chemistry. And then researchers noticed something else about those shrimp. When they cluster together in dense groups, they feed on the bacteria around them. When they spread out and food gets scarce, they turn carnivorous. They start eating snails. They start eating other crustaceans. And when scientists analyzed what was inside their digestive systems, they found fragments of the most abundant crustacean in the area, which is the shrimp itself. They are cannibals. But even that is not the strangest thing living in the deep. In 2006, a research team supported by the NASA Astrobiology Institute announced they had found something inside a gold mine in South Africa, 2.8 kilometers underground. A community of microorganisms living inside water-filled cracks in ancient rock. The water they were living in was dated at tens of millions of years old. These organisms had had no contact with the surface world for longer than modern humans have existed as a species. They were not drawing energy from sunlight. They were not drawing energy from anything connected to the surface biosphere. They were feeding on hydrogen and sulfates produced by the slow radioactive decay of minerals in the surrounding rock. Completely isolated, completely self-sustaining for tens of millions of years. One researcher described them simply: by any reasonable definition, this is an alien form of life within the Earth. And here is why NASA cares deeply about all of this. Jupiter has a moon called Europa. Beneath its icy surface, under roughly 12 kilometers of frozen crust, scientists believe there is a liquid water ocean. At the bottom of that ocean, the pressure is estimated to be roughly equivalent to the pressure in the Earth's Hadal Zone, the deepest trenches, the places Orpheus is designed to explore. That is not a coincidence. Saturn's moon Enceladus has geysers shooting liquid water into space from beneath its ice. Mars once had lakes and rivers and possibly oceans.
As the planet dried and cooled, those bodies of water grew saltier, more chemically concentrated, remarkably similar to the brine pools scientists have found on the floor of the Gulf of Mexico, sitting 5 times saltier than the surrounding ocean above ancient Jurassic salt beds. The logic connecting all of these dots is straightforward. If life can exist in total darkness in the deep ocean, if it can survive in solid rock for tens of millions of years powered by radioactive decay, if it can thrive in water so hot it should destroy every biological molecule, then the only thing life actually requires is this: rock, water, a source of chemical energy. You don't need a star, you just need geology. And that idea, that simple, profound idea, is exactly why NASA spent years building a motorcycle-sized robot named after a figure from Greek mythology and sent it to the bottom of the ocean. They are not just studying Earth, they are rehearsing for Europa. Now, we need to talk about what's actually making that oxygen.
His name is Andrew Sweetman. He's a marine scientist. And for years, his data was telling him something impossible, and he refused to believe it. His team was running experiments in the Clarion-Clipperton Zone, a stretch of abyssal seafloor in the eastern Pacific that spans 4,500 kilometers. They were lowering sealed chambers onto the seafloor, trapping small patches of the ocean bottom and measuring what happened to oxygen levels inside. Normally, when you seal off a patch of seafloor, oxygen goes down. Organisms consume it. That is how respiration works. That is how it has always worked everywhere on Earth. But here, the oxygen was going up. He assumed sensor malfunction. He threw the sensors away, bought new ones. Same result. He ran it 25 separate times. Same result. He poisoned the water with mercury chloride to eliminate every living organism inside the chambers. The oxygen still rose. In some experiments, levels climbed to more than 3 times the starting concentration over roughly 47 hours. And then in 2022, Sweetman was watching a video about deep-sea mining and heard someone describe the lumpy mineral deposits scattered across that seafloor as, and this is just a marketing phrase, nothing scientific, a battery in a rock. He stopped the video. The seafloor of the Clarion-Clipperton Zone is covered in what scientists call polymetallic nodules. They look like lumps of charcoal, the size of a potato. They grow at an almost incomprehensibly slow rate. A single nodule might take millions of years to reach the size of your fist, accumulating layer by layer as metals precipitate out of seawater and settle on the surface. Manganese, cobalt, nickel, copper, iron, each layer slightly different in composition from the one before. Sweetman's team tested the electrical potential on the surface of 12 nodules using platinum electrodes across 153 different measurement sites, and they found voltage potentials of up to 0.95 volts on individual nodule surfaces. A standard AA battery produces about 1.5 volts. To split seawater into hydrogen and oxygen through electrolysis, you need roughly 1.23 volts, more than any single nodule produces alone. But that threshold can be reduced significantly if the reaction proceeds through a specific chemical pathway, and if the nodule surface contains the right kind of metal catalyst, which it does. Manganese oxides enriched with nickel, with large internal tunnel structures, with surface defects that optimize how reactants bind and react. The leading hypothesis is this: these nodules, these ancient, slowly grown lumps of minerals sitting in total darkness at the bottom of the Pacific, may be functioning as natural geobatteries. The voltage difference between their internal layers drives a redistribution of electrons, and when that electrochemical activity meets seawater at the nodule surface, it may be splitting water molecules apart into hydrogen and oxygen. Rocks making breathable air 13,000 feet underwater, in complete darkness, with no sunlight, no biology, no life of any kind involved. The study was published in Nature Geoscience. The oxygen production was correlated directly with nodule surface area. More surface area, more oxygen. That is exactly what the geobattery hypothesis would predict. Now, the researchers are careful. This is a hypothesis, not a confirmed mechanism. The production slowed and stopped after about 2 days in sealed chambers. Whether it continues indefinitely in open ocean conditions remains genuinely unknown. Some scientists believe disturbing the nodules with the lander may have triggered the reaction by exposing normally buried electrochemical surfaces. Others believe it happens naturally, continuously, right now, across thousands of kilometers of abyssal seafloor. If they are right, if this is real, then for the first time in the history of biology, we have found a source of oxygen on Earth that has nothing to do with life, nothing to do with the sun, just mineral chemistry running quietly in the dark at the bottom of the ocean, possibly for millions of years. As one researcher put it, this really strongly goes against everything we have traditionally believed about where oxygen comes from and how it is made. And now consider this final thought. If polymetallic nodules can produce oxygen through electrochemical reactions in Earth's deep ocean, there is no obvious reason why similar mineral processes could not occur on the floor of Europa's ocean, or Enceladus, or wherever liquid water has spent millions of years in contact with mineral-rich rock. We went to the bottom of the ocean looking for data. We found a mirror. Every dive Orpheus makes in the dark Atlantic, every oxygen reading that defies expectation, every blind shrimp clinging to the edge of a hydrothermal vent, every microbe surviving in a million-year-old crack in solid rock, they are all pointing at the same thing. Life doesn't need what we thought it needed, and oxygen might not need life. The universe just got a lot more interesting. If this video made you think differently about something, share it with one person, just one, and stay curious, because the deeper we go, the stranger it gets.